we'll see about conversion of push-down automata to context-free grammar. If you are given with a push-down automata, PDA of M of Q sigma Q naught A delta gamma and Z naught, then we can have an equivalent context-free grammar VTPS. That is, the language accepted by the push-down automata will be equivalent to the language accepted by the context-free grammar. So that is what we call it as, if we have a push-down automata, then we can construct a context-free grammar which is equivalent to the language accepted by the push-down automata. Now, if we have a push-down automata, if we want to convert that into a context-free grammar, we should be able to define all these four tuples, because the context-free grammar G will be defined with the help of only these four entities. V is the set of vertices or set of non-terminals. T is the set of terminals. This set of terminals for this context-free grammar will be always equal to the input symbols of push-down automata. Input symbols of push-down automata. And S is the start symbol. Usually, we will use a special symbol S, which will be the start symbol for this context-free grammar. And P is the set of productions. Set of productions. So in conversion of a push-down automata to context-free grammar, our set of terminals is going to be the same as that of the input symbols of push-down automata, and we are going to assume a special symbol S as the start symbol of context-free grammar. So now our task is to define the rules for how to specify set of non-terminals and set of productions. So what can be the possible set of non-terminals or variables? So as I've told you, we will introduce a special symbol S, which is going to be which will be acting as the start symbol for the context-free grammar. Second is, we will have the set of variables PXQ. So PXQ is going to be our variable. So this belongs to the set of variables for all P, Q belonging to capital Q, set of states, and X belonging to the tape symbols. Suppose we have the set of states as Q0, Q1, and the tape symbols as A and Z0, then the variables can be Q0, A, Q0, Q0, A, Q1, again Q0, Z0, Q0, Q0, Z0, Q1, likewise Q1, A, Q0, Q1, A, Q1, Q1, Z0, Q0, and Q1, Z0, Q1. Q1, Z0, Q1. So this P and Q, you have to accept all possibilities of Q. So if your Q is going to be Q and Q0, this is what the possibilities. First we'll be taking Q0, 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 and we'll be varying with Q0, Q0, Q1, Q1. Again we'll be taking, because we have two tape symbols, A and Z0. So there will be four possibilities with Q0. And then again with Q1, we'll be having four possibilities. So all these things along with S will be our set of vertices or set of variables or set of non-terminals if we have a push-down automata with state with Q is equal to Q0, Q1 and tape symbol is equal to A, Z0. Now this is what is the two rules for defining the set of variables. Now coming to the set of productions. First we will introduce start symbol production. So first is start symbol production. So we will introduce a production S goes to Q0 is the initial state, S0 refers to the bottom of the stack with some P here for all P belonging to capital Q. So in our example, if your set of states Q is equal to Q0 and Q1, so what can be the start symbol? Our start symbol will be Q0, Z0, Q0, and S goes to Q0, Z0, Q1. So these two will be the start symbol. Start symbol productions we will include if we have the set of states like this. This is for example I am telling. So this is our first rule. Second rule is, suppose you have the production of the form delta of Q comma A comma X. This is equal to some R comma epsilon. Suppose you have a production like this. Say for example, this will come for pop operation, pop production. So if you have A as input symbol and X as some stack symbol, and you are, in that case, you are moving to another state called R with a pop operation. So if you have a production of this form, then you have to include your if you have a transition of this form, then the corresponding grammar will have a production of this Q, you will write here, then this X you will write here, X, and this R you will write here. This is going to be your left hand side. This is a non-terminal, okay, tending to this A you will be including, this A you will be including here. This is how you will write the production. Say for example, if I have delta of Q0 comma A comma Z0 is equal to Q1 comma epsilon. If I have like this, then I will be writing it as Q0 Z0 Q1 tending to A. This is an example. This is how we will be writing for pop operation. See, if your input symbol is A, if you have something in the input tape, then you will be writing like this. Suppose third rule is, if you don't have anything in the input tape, it is pointing to epsilon and some stack symbol is there, and you are performing one pop operation. In that case, the same thing XR, but you will be replacing that with epsilon. This is rule number 3. Say for example, we will take one production delta of Q0 comma epsilon comma Z0 tending to Q1 comma epsilon. Let us assume you have a production of this form. Here epsilon. Okay. So in that case, Q0 Z0 Q1 tending to epsilon. This is how we need to represent the corresponding production for this transition, corresponding production for this transition. Now the fourth rule, see these two we have, this one is for start symbol. This production we are including for start symbol. And these two production we are including for these two productions. Rule number 2 and 3 we are including for pop operations. Okay. And for push operations, suppose you are having a production of the form A comma X, which is equal to R comma, you are pushing some K elements, let us assume. This is the condition. Okay. In that case, see our right hand side will be this one A, not a problem. Next is X, we will be adding X. And here this RK, you have to apply all possible combinations of states for this R. Suppose you are going to take state Q0, Q1, then all possible states Q0, Q1, everything you should have for this RK. And the right hand side should be, this A should be here. And suppose you have K number of symbols in the stack, then there should be K brackets like this you should have. with first stack symbol, second stack symbol, third stack symbol in the middle, and this R you should start with R followed by all combinations of R you have to make. See, R1 followed by R1 with R2. Likewise till Rk minus 1 till Rk. So suppose you have k number of stack elements, then you should have k brackets in the right hand side. K brackets in the right hand side. So let me take one example and explain this rule clearly. Here again we'll consider our set of states as Q0 and Q1. Okay. Let me take one transition. Let it be Q0 comma. Let us assume that I have A comma Z0 tending to Q1 A Z0. Okay. So whenever I have A Z0, I am moving to some other state with a push operation. Let us assume this is our push down automata transition. And we have two states Q0, Q1. Here two symbols we have. If we have two states and two symbols, we will have four combinations. We will have four combinations. Let me tell you how. Say for example, this right hand side, it should start with Q0, Z0, no doubt. Okay. Likewise, Q0, Z0. See, this Q as well as R should be all possible combinations. So you have to take as, see, this is Q0 only, no chance, Q0, no choice. Okay, initial, this state only, whatever is there, you will be copying it here. And this will be Q0, Q0, Q1, Q1. Okay, so we'll have four combinations if we have two symbols, two stack symbols. So this one you have to copy here, the same thing. So A. Now you will start with this symbol. Okay. Let us assume you have a Q0 here. Okay. So Q0, A, Q0. Okay, this R only you have to use. So I'm starting with Q0, Q0, and again Q0, Z0, Q0. Here Q0, A, Q1, because the next possibility I have to take, and this also Q1, Z0, same possibility, Q1, Q0. Here I can take as Q0, A, Q0, and Q0, Z0, Q1. Q0, A, Q1, Q1, Z0, Q1. See, if I'm doing like this, only then I'll be considering all possibilities for this RK. See here, all four production is different. See, if I have two symbols, you keep in mind, if you have two symbols in the right hand side, then there will be four production. There will be four production. So this Q0 you have to copy here in the first column. This Z0 you have to copy in the second column. And all the set of symbols Q0, Q0, Q1, Q1, that should be varying here. That you have to make it here. Whatever symbol is there, you have to start only with this one. And the first cell will take the first stack symbol and the second cell will take the second stack symbol. So starting with, you need to go with all possible combinations. So Q0, Q0. Again, this and this should be one and the same. That's what is given here. R1, R1. It should be one and the same. So Q0, if it is Q0, then Q0, you go to Q0. Q1, then Q1, go to Q0. Then Q0, Q0, go to Q1. Q1, Q1, go to Q1. These are all possibilities of RK we are considering.